Here we go. We have a question missing and repeating. So you have given an unsorted array of positive integers. So one number is missing and one number occurs twice. We have a range of 1 to n. You need to find those two numbers and return in an array. In the first example, number 2 is repeating and number 1 is missing, and the repeating number occurs two times only. In this example, number 3 is repeating and number 2 is missing. So let's build the approach. Before jumping into the approach, there are many approaches to this question, but I will tell you the most optimized approach. So in this question, we're gonna apply XOR operation. So I hope you are already familiar with the XOR operation. If you are, then you can skip this part. Otherwise, I will just give you a gist about it. So this is an XOR operation. If the bits are same, so it will give us 0. If the bits are different, then it will give us 1. So if I do the XOR with the same number, means x XOR x, example 5 XOR 5, it will give us 0. So this is 5 and this is 5. If I do the XOR, the bits are same. So for the same bits, the answer is 0. So this is the operation that we need. So first we do the XOR of all the numbers. So we have all the numbers. Next iteration, we know the array length is n. We know the array length is n. One number is repeating, one number is missing. So the array length stays same. So in this in this sample test case, the range is 1 to 12. So we also need to do the XOR between 1 to 12. So we also need to do the XOR between 1 to 12. So XOR variable contains the XOR of all the values and the range. So this property will apply here. We have to believe that the same number will cancel out each other. So the same number will cancel out each other. 1 will cancel out 1, 2 with 2, 3 with 3. That's it. So at the end, we have a number whose frequency is odd, or which occurs odd number of times. So 5 occurs 3 number of times because 2 times in this array and 1 time in the range, and 9 occurs 1 time because 9 is not present in the array but present in the range. So at the end we have XOR of 5 and 9. So we have XOR of 5 and 9 and all the other numbers will cancel out each other. So let's write 5 and 9. So this is 5 0 1 0 1 and this is 9 1 0 0 1, and if we do the XOR is this 1 1 0 0. The next step is to find the least significant bit, the LSB. One way to find the LSB is to traverse from right to left. So in this case, the LSB is this. LSB is this. But there's one optimized way to find the LSB. So let me tell you the optimized way to find LSB. Let's suppose we x 1100, like in this case. So first we need to find x minus 1. So if I do x minus 1, it will give me this. Next we need to inverse this. We need to inverse this. So inverse means if the value is 1, it will convert to 0. If the value is 0, it will convert to 1. So if I do the inverse, on the next step I have to do the AND operation. I have to do the AND operation. So our x value is this and our next value is this. So after finding out this, we need to do the AND operation. So if I do the AND operation, we have our LSB. How this will work? Because we are subtracting one value, so it will change this position. It will change the least significant position, and all the values on the other side will convert it to 1, will be converted to 1. So if I converted those numbers, we need to find this changed this changed bit. We need to find this changed bit. So if I do the inversal, and if I do the AND operation, we have our LSB. So for this test case, we have our LSB as this. Let's take one another case. If I have this x, so we need to first find x minus 1. Our x minus 1 is this. Next we need to inverse the bits. If I do the inversal operation, we have our value as this. Next we need to do AND operation. So if I do the AND operation between x and x minus 1 inversal, so our resultant is this, and we have our LSB. As you can see, this is our LSB for this value. So let's take one another case. This is the last case. We have x value as this. We first need to find x minus 1. On the next step, we need to inverse the bits. If I do the inversal, on the next step, we need to find the AND resultant. So the value, the answer is this. We have x and inversal of x minus 1. The resultant is this. So this is our LSB for this x value. So now we know how to find the LSB. So let's continue our question. We have XOR as 5 and 9. So our value is this. For this value, for this value, our LSB is this 0 1 0 0. So this value is 1. The LSB value is 1 is because one of them one of them is off, and one of them is on. So one of them value is 1 and another one is 0. That's why our XOR is 1. That's why our XOR is 1. So we are sure our next step is to divide the array into buckets or variables. So let's first take the array. We have this array and we know the LSB, first position, second position and third position. Its third position is set. Set means its value is 1. Its value is 1. So we need to divide the values into buckets. So here third bit is set and here third bit is off or not set. So for 5, if I have to write 5, 5 is 101. So 101, its value is set. So 5 is here. Next we have 7. 7 is 111. So 7 also belongs here. Next 2 value is not set. 3 value is not set. 1 value is not set. Then we have 5. 5 is 101. So 5 value is set. Next we have 8. 8 means 1 then 000. So its value is not set. Next we have 6. 6 means 110. So 6 value is set. Then we have 12. So 12 means 1100. So 12 value, 12 third bit is also set. Next we have 4. So 4 value is also set. Next we have 10. So 10 means 1010. So 10 value is not set. Next we have 11. 11 is also not set. So after dividing the values into buckets, here the actual bucket is a variable, and we have to do the AND operation. We have to do the AND operation between them. So we have filtered out the numbers, the values, the elements, but we also need to filter out the range of 1 to 12, because when we find the XOR, when we found our XOR, so XOR is find by XORing the elements and the range. So we also need to filter out, we also need to separate the range of 1 to 12 into buckets. So the range is 1 to 12, and as you can see, 1 belongs here, 2 belongs here, 3 belongs here, 4 belongs here, 5 belongs here, 6 belongs here, 7 here, 8 here, and 9. So 9, if I have to write 9, 9 is 1001. So 9 is also not set. Next we have 10, next we have 11, and then we have 12. So the same value will cancel out each other. 5 will cancel out 5, 6 will cancel out 6, 12 will cancel out 12, 7 will cancel out 7, 4 will cancel out 4. So we have a single value here, which is 5. Same goes here. 1 will cancel out 1, 2 to 2, 3 to 3, 8 to 8, then 11 to 11, 10 to 10. So a single value is present here. So A value is 5 and B value is 9. So we have found out the missing value and the repeating value, but we are not sure whether A is repeating or B is repeating. So on the last iteration, we have to iterate between the elements, and if the element is equal to A, it means A is present in the array. So A is repeating. So A is repeating and B is missing. If the value is equal to B, so we are sure B is repeating and A is missing. So that's how we find the missing value and the duplicate value. So that's about this question. Let's code this. So we have some variables XOR A, B and N. On the first iteration, we have to do the XOR operation between the elements and the range. The range is between 1 to n, and we are sure the array length is n, and we need to do the operation of XOR between the range of 1 to n. So I will do this I plus 1. So after finding out the XOR operation, after finding out the XOR, we need to find the LSB. So that's how we find the LSB. After finding out the LSB, we need to iterate in the array, and we need to put the values in the bucket of A and B. So this is just for calling. The actual bucket is a variable, and if LSB and the element, if I do the AND operation, it means the value is set. If I do the AND operation and the resultant is not 0, means LSB value is set and the element value is also set. So that's why the resultant, the AND operation, is greater than 0. So we put the value in A bucket, else the bit is off, we put the value in B bucket. So we have filtered out the element. Next we need to filter out the range between 1 to n. If the value is set, so we put in A bucket, else we put in B bucket. Then on the next iteration, Now we have found the value of a and b, but we are not sure whether a is repeating or b is repeating. If a value is present in array, it means a is repeating. If b is present in array, we are sure b is repeating. So next we need to write something, so that's why I have written -1 and -1. So let's give it a try, and let's talk about time and space complexity. In this case, we have several iteration and every iteration is of length n. So our time complexity is order of n and space complexity is constant. So we have met the expected time and space complexity. Code is given in the description box.